Okay, so we're back into part two so that we can finish this up. And where we left off is we had 484 meters squared per second squared over 88 meters. And when we do that, we come up with 5.5, okay? But there is one thing that I forgot to carry down, and I've got to make sure that we carry that down, is this negative sign. So this is all negative. So I've got to remember what I put here is going to be negative. So this is going to be 5.5. And then when we look at units, it's going to be meters per second squared. If we pull out these units here, okay, we've got the square canceling out the meters there, leaving us with meters per second squared. All right, and so that's how you do that one. So let's do the very last one, number 7. And again, we're going through the guess method here. So let's look for our givens. A prototype racing car of a mass, which is 500 kilograms, accelerates starting from rest. Okay, so we know that thing is going to be accelerating. The car reaches a speed of, so we've got a speed of 40 meters per second and a time of 10 seconds. So let's write some of that down. We've got, again, a mass of 500 kilograms, a speed of 40 meters per second, a time of 10 seconds, and then our unknown for this one is how far has the car traveled during this amount of time. All right, so that is our unknown, how far. We don't know that. Now there's one more piece of information that's there, and I left it out on purpose, just hopefully you caught it, which is from rest. Remember, we've circled that several times, and that is that your initial velocity is 0 meters per second. All right, so we need to go look for an equation on this one. Okay. Okay, so the equation that we want to use, there's actually going to be two of them, but the first one that we want to use is we need to know the average speed of the car, because we need to know how far it's going, and how far it's going, okay, will depend on the velocity and the time. So if you remember back to the basic formula for velocity, an average velocity, we just need to know the total displacement over the total time, and then when we rearrange this and solve for displacement, we will get displacement is equal to the average velocity multiplied by the time, because all we've got to do is get rid of time here and multiply this side by time also. So v times t gives us displacement. Now we don't have an average velocity, unfortunately. We only have the initial velocity and the final velocity. So let's figure out how do we get average. So here's the average velocity formula. We take the final velocity plus the initial velocity and divide by 2. So let's plug in some numbers here. The final velocity was 40 meters per second, and the initial velocity was 0 meters per second. And then we'll divide that by 2. Well, 40 plus 0 is 40. Divide that by 2, and we get that the average velocity was 20 meters per second. Okay. So now we can come back to this formula and plug in some numbers. So let's do that. Your average velocity multiplied by time. Well, our average velocity we figured out was 20 meters per second, and the amount of time was given to us in the problem, 10 seconds. So 20 times 10 gives us 200, and since this is displacement, it would be meters. This is displacement or distance would be meters. So the seconds here cancels out seconds, and we get meters. And that's it. Now, go ahead and practice. We both know, Maria, Miss Segovia, and I know that this just takes time. You have to do practice. You just have to do these things and start getting in and working with them. Some people catch on really quickly, others you just have to do more practice than others. So just keep practicing, just keep practicing, just keep practicing.
You can do it.
You can do it.